This is the story of superconducting maglev transportation. The inventions of two distinguished American and Canadian-born scientists, Drs. James Powell and Gordon Danby, are yielding an extraordinary new surface transportation capability. Their early inventions have been implemented by the Japanese to build a first-generation ultra-high-speed superconducting maglev surface transport system. Powell and Danby have not stopped inventing and have moved far beyond their early designs, creating advanced patents for transportation, grid-scale energy storage, and maglev space launch. Their new designs enable more powerful lift capability, electronic switching of vehicles, and substantially lower guideway construction cost. Superconducting maglev can now deliver a faster, better, and cheaper 21st century freight system. Their new second-generation maglev system is a major advancement beyond present passenger-only maglev systems. Not only will it transport passengers, but also highway trucks, automobiles, and fresh water. It can be adapted for levitated travel along existing railroad tracks, and it can store enormous amounts of electrical energy to meet peak power demands. The Maglev 2000 second-generation system has much lower cost guideway, much more capable quadrupole magnets, and much greater lift capability. No other transport system in the world today provides its unique, cost-effective capabilities. Second-generation maglev is described in Powell and Danby's recent books, Maglev America and The Fight for Maglev, available at Amazon.com. To stop at offline stations, first-gen maglev vehicles must use a mechanically moving switch on the guideway that leads to the offline station. Average travel speed decreases, increasing trip time. Second-gen maglev vehicles do not need mechanical switches. They electronically switch at high speed from the mainline guideway to the secondary guideway leading to an offline station or truck terminal. Average speed will be greater and trip time shorter. The second-generation system implements quadrupole magnets using high-temperature superconductors. Its new design makes large-scale maglev network construction viable. Second-gen vehicles will operate in the skip-stop mode, bypassing stations at high speed that they are not scheduled to stop at, only stopping at their scheduled stations. Skip-stop operation will enable many more stations on the main line with more convenient access for travelers and cargo. The Maglev 2000 patented MARY system enables maglev vehicles for levitated travel above adapted existing conventional railroad networks to access urban and suburban areas without the need to build guideways within them. Maglev vehicles have no wheels, are magnetically levitated above and propelled along guideways at hundreds of miles per hour with no mechanical contact. The fare cost per passenger mile is less than highway driving. The cost per ton-mile of shipping is much less, dramatically reducing the costs of goods for everybody. Imagine a 30,000-mile national maglev network that moves goods and passengers between cities and ports at speeds rivaling aircraft. Maglev 2000 and Readiness Resource Group have defined a multi-year test and construction program for a national interstate maglev network. Transporting trucks on the national maglev network will result in fewer highway deaths, injuries, and accidents, less congestion and time lost in traffic, and lower emissions of toxic pollutants and greenhouse gases, while greatly reducing the cost of freight transport. The economic benefits in jobs, lower cost of transport, new industries, and increased exports will be tremendous. Long-haul trucking will have the competitive advantage of moving goods for their customers at speeds 5 times as quickly as current roadways permit. Produce to market more promptly, longer shelf life, less waste. Our overburdened highways will have greater durability when autos and trucks travel by maglev, reducing the cost to taxpayers for highway upkeep. Consider taking your personal vehicle hundreds or thousands of miles for business or leisure travel on maglev, not by highway, with trip times of hours, not days. Our decaying present surface transport system constrains our ability to compete in the global marketplace. It's time for a new generation of critical infrastructure for the next century. Maglev is not a futuristic fantasy. No other technology has as much potential to handle the projected doubling of freight transport. Superconducting Maglev industry will greatly enrich our economic security and quality of life in the 21st century.